Hey everyone, so we are here to solve this particular question named arranging coins. So what we have to do in this particular question is we have given a natural number n, okay, a natural number n, and we have to fill this in stairs, okay. So in stairs, what I meant is in first row we can only fill one coin, in second row we can fill 2 coins, in third row we can fill 3 coins, in fourth row we can fill 4 coins, right? So simultaneously in nth row, in kth row, let's say this is kth, in kth row we can fill k number of coins, okay. So hope this particular now we have to find this particular k, and before of the k, basically we have to find the number of stairs which are complete. Now by complete, what I meant is it can be possible that in last row we don't have enough coins to complete this particular row, right? Is this so let's take the example of 5. So in first row we have filled first 1 coin, in second row we have filled 2 coins, in third row we have filled 3 coins, okay. Now total 1 2 3 4 5, so we can only fill these particular coins, right? And this particular row is incomplete. Now we have to return all the complete rows, those are 2, right? So hope the problem statement is clear in this case. Now just think for 1 or 2 minutes how you can solve this question, okay. So let's continue towards its solutions, okay. So solution number 1, okay. Now for this particular solution we can just fill the coins, right? And whenever we have found that there are insufficient number of coins or insufficient number of coins, we can just return the number of rows. Whenever we found that for this particular row we have insufficient number of coins, so how can this be possible? So let's say we have for first row we have filled first 1 coin, and we have decrement our total number of coins by 1. For the second case we can decrement total number of coins by 2. So for this n, okay, for this n dash, or let's say this new n, okay. So for this is basically a new n, that means this is basically n minus 1 n minus 2, okay. Okay, so for 3 it must be n minus 1 n minus 2 n minus 3. And whenever we have found out that we have insufficient number of coins to fill in this particular row, we can return the current number of count. So we can just implement a for loop, okay. And for each I we can just return for each I we can increase our local variable result, or we can okay, we can just increase total number of results, okay. And here we can return result, okay. Now we have to just check are the number of coins good for this particular case, or so in this way we can solve this particular question. So for example, let's cut So let's basically do this in different manner. We can just draw while loop which would always be basically infinitely, which can run infinitely, and we can just decrement our n each time. Okay, so first k would be 1. Okay, and this is given. Okay, now we have to just increment this particular n. So first of all we can check, is n minus k, which is basically currently 1, is this less than or equals to 0? If yes, then we can increase our result. If this returns true, we basically increment our result, and also we will increment our k variable, right? So now we will search for 2. Okay, so now k would be 2, and we can find. Oh, and one more thing, we have to change our n by k, n minus by k. Okay, now let's focus towards our new solution, second solution. Okay, so for this solution, so first of all, how I came across this particular solution, basically what is the intuition behind, is we have to find the maximum k. Okay, from which all the k's greater than it are invalid, correct? So let's say for this particular k, all the k towards its right, let's say this is 500. Now all the k towards its right, which are greater than 500, are invalid, and all the k's towards left of it are valid. So that is how I got the intuition to use binary search here. Okay, now hope this is clear. So for example, let's take few examples. So for example, for 25, right, 1 is greater than 25, right? So that means this k is our solution. So for first k, for 1k, I can easily think about that. 1 for 1 for 1 so for 1 can be easily filled, right? Because we have 25 coins. Now for second number, I will have in this case 24 coins, that and minus 2, that means 22 coins. Now 22 are also valid coins. So I can now step down to third row. Now 22 minus 3, that means 19. Now 19 is also valid, correct? So at one particular point we can have reached such k which would be invalid in this case, right? So all the numbers before this would be valid, and all the numbers greater than or equal to k would be valid in this particular case, right? So that is how I got the intuition of binary search. You can search various implementations of it, okay, in web. Now there is also third solution, which is mathematical one. Now what this particular solution says is, we have to find this particular k, right? This kth number, that means this k, for which the sum of these particular numbers must be less than or equal to n. Correct? Is this valid? Is this good in your case or not? Tell me this, because first row is filled, second row is filled with 2, kth row would be filled with k, right? But in this case, k can be k can okay, and okay, now we know this kth row can must be filled, and we have this invalid number of n's. Is it correct or not? This kth row, these are all the rows which are completely filled, and these are some invalid number of rows. This can be 0 to k plus 1, k minus k, right? 0 to k. Okay, now sum of we know sum of n natural numbers can be written as k into k plus 1 upon 2, right? Plus some number I. Right? Now we have to remove this. We don't have to count this, right? Is this because that is what solution our question says, right? Now this particular equation can be solved. Plus k plus 1 is equal to 2n, and k square plus k plus 1 minus 2 minus 1 plus minus 2n, correct? And k can be written as, now this is basically a quadratic equation, right? And we know how we can find k's which solve this, which is the solution of this particular equation. Okay, now we can remove this in this case, because we have to find the upper limit only, correct? So k would be minus b plus minus under root of b square minus 4. Hey, wait a minute. K square plus k plus yes, 4ac 2n, right, upon 2a minus 1 plus minus square root of 1 minus 4 plus 8n, correct, upon 2. Right? So now 1 plus minus square root of 1 minus so this can be written as minus 1 plus minus square root of 8n minus 3 upon 2. Now as we know, our the constraints of the basically the constraints of this question says that n can only be lied between n to integer dot max. Okay, so and if you fill this in basically into those two equations, only one would be valid, that is plus square root of 8n minus 3 upon 2, because the second equation will always return in this number to be iota, because this would always be negative number. Oh, sorry, not iota. I'm sorry. So for this case, all of this equation would basically, for this case, minus 1 minus square root of 8 and minus 3, for this particular case this will always be a negative number. And as we know that number of rows cannot be negative, or should always be greater than 0. Okay, because we can at least fill one coin. Okay, okay, so that is what I wanna say. And this will always, basically this will give us an exact number. Okay, by exact number what I meant is this will return a double. And as we know, our row cannot be in fractions, right? So by just converting it to an integer, by basically passing it to an integer, we will have the correct solution. This is what this solution says, correct? So that is how we can found kth step. Okay, and now there is one more solution to it that can be solved using bit manipulation. And what this basically solution is, as we know, we can have a limit to n, which is integer dot max, correct? Now in binary form, integer dot the number of basically number of digits to n. Number of digits to n would be 31 only. Am I right? Correct. And how we can find this particular 31? We can just make log to the base 2 of integer dot max, and this will return us basically by this particular basically whenever we have to find the number of places, number of digits in binary of an integer number, we can just take log to the base 2 of that particular number. In this case we can find out the number of digits. So similarly, k into k plus 1, k into k plus 1 by 2, right? This is almost basically we can take basically at max k square, right? Now we have to find why I'm saying k square, because this can be written as k square plus k by 2, right? And k square by 2 plus k by 2, right? And k square plus now the digits, number of digits in this particular case, as you know, that would be log to the base 2 by integer dot max by 2. Am I right or not? Right? That is how we can find the number of digits in k. Okay, now what we have to do is we can just take a mask which will mask and write it by 15. That means 15 we are just taking a mask and we will just trying to fill 1 in each case of our result. So let's say we are filling 1 to the first number and just checking if this particular number का square is equals to n is less than or equals to n or not. Okay, if we are getting this, then we are good to go. We can just directly fill 1 to our result. Basically we can just write it to here. Okay, we can just directly put a result which would be initially set to 0. We can just set result to result or mask, right? So in this case we will have 1. Okay, otherwise we will just change this one to here, and again check if we can fill this particular one in this particular case. If yes, then again good to go. And finally we will have our particular number of ones which will be our answer. So for example, 1 can be here, 1 can be here, V1 can be here. We are basically filling from left to right, basically from higher digit to lower digit to find particular solution. Basically if we can fill 1 here or if we can fill 1 here so that is how we can solve this particular question using these methods. Okay, thanks everyone. I know if you find this okay, so that is all from my side. Thanks everyone. Let us see you next time. Let's meet next time. Thank you.